going to talk to you about is not so much how to go to Mars. We heard about that in the previous session. I'm going to talk about why to go to Mars. Fundamental science question we have about Mars is, did it start there? Was there a second Genesis? So what we're searching for, the big prize, is life, but not as we know it. Here, of course, is Spock and Kirk in Devil in the Dark, episode 26, the original series. You all remember it, of course, where Spock uses his tricorder not just to detect light, but to detect silicon-based life. Quite a remarkable tool. We need his tricorder. And, of course, then they shoot it. So where are we going to search for evidence of life? Well, there's lots of worlds in our solar system where we could look. Other worlds with liquids, Mars, Europa, Enceladus, and even Titan. Mars is the closest, and it's also unique in that of all these worlds of astrobiological interest, it's the only one that also is of interest from the point of view of human exploration. That's what makes Mars unique. Not that it's the best place in the solar system to search for evidence of life, but that it's the only place in the solar system where the scientific interest in the search for evidence of life connects with the human interest in human exploration and long-term activities on Mars. The reason we now worry that if we go to Mars and find life and it is not a second Genesis, it is part of our same tree of life, is because we now know that rocks have been knocked off Mars, flown through space, and landed on Earth. We have in our meteorite collection some 20 or so rocks that have come from Mars. We know they come from Mars because on the bottom there's a little plaque, made in Mars. No, not really. But just as good. We know they come from Mars because inside these rocks there's little air bubbles of gas, and the gas has the same composition as the Martian atmosphere as measured by Viking. It was saying searching for fossils is not enough. Searching for life is not enough. We want to search for a second Genesis. To find that, we need an actual organism because we want to map it on this tree. We need to look at its genetic material and see if it's DNA. And if it is, how does it compare to the DNA in all life forms on Earth? So the mission concept is a lunar plant growth module. It's a precursor to Mars. Story 3 takes the story of life to Mars even further, and that is making Mars habitable for life, long-term habitability. We know that Mars is a planet with a past, a past that was wet. Here is a world that was wet. It was a water world. At one time, we had 2 blue marbles in our solar system. Somewhere along the way, we lost one of our marbles. How do you bring Mars back? Well, the fundamental challenge here is to warm up the planet. We know how to warm up planets. We're doing it right here on Earth. We are practiced in that technology. And in fact, you could do the same thing on Mars, and you can imagine today and in the future, you notice the difference? So I think an important motivation for investigating Mars, investigating life on Mars, investigating the possibility of bringing Mars back to life is the fact that we humans, whether we want to or not, must assume management responsibilities for our planet. There's just too many of us not to assume management responsibilities. It would be a dereliction of duty not to assume that we are responsible and must take it. And we have to learn how to do that, and one of the ways of learning how to understand something is investigating how you would create it.